Hi there, my name's Keith Milner and I live in the United Kingdom. And this lesson is about distortion. Distortion is caused when a signal is altered due to non-linearity in the piece of equipment it's passing through. Most commonly when we talk about distortion, we're talking about distortion caused by signal overload or a signal level being too high. And distortion in this case is normally a bad thing. However, there are musical uses of this distortion, as we shall see. I'm going to demonstrate the impact that a hard limiting distortion, such as that caused by digital clipping, can have on a signal. In this case, I'm going to use a compressor, which has a threshold set at minus 12 dB. I will set the ratio to maximum, which will basically form a hard cutoff at minus 12 dB. I'll be feeding this with a sine wave, which will be visible in this oscilloscope display here. The red line represents the hard cutoff level of minus 12 dB. Below in the spectrum analyzer, you'll be able to see the frequency response of the resulting signal. I will generate a full 40 Hz sine wave and turn the level up until it hits the limiter's threshold and starts to distort. The oscilloscope on the right hand side should show a green line, which is the signal level, and a red line which represents the limiter's threshold level. At this level, the signal hasn't reached the limiter threshold level yet, so it's undistorted, as can be seen by the oscilloscope display. And in the spectrum analyzer display, we have a single peak representing the single 440 Hz frequency. And of course, the sound is very pure. If we turn it up to get some distortion, at this level, you can see the peaks of the sine wave have been cut off by the limiter. And in the spectrum analyzer display, we're starting to see additional frequencies, additional harmonics creep in. And these are evident as a timbre change. The more we turn it up, the more it distorts. The more higher frequency content we have, and the greater the timbre change. But what is the impact of this sort of distortion on real-world recordings? To demonstrate this, I'm going to play back a recording of some singing through this limiter to demonstrate the situation where the levels have been set too high during recording and digital clipping has occurred. First, we will listen to the undistorted recording by bypassing the limiter. If you look at the green signal level on the oscilloscope, you should see that peak well above the red line, which represents the limiter's threshold level.
Do, re, mi, fa, sol, la, ti, do.
If we place the limiter back in line and play the recording again, you should see and hear the distortion.
Do, re, mi, fa, sol, la, ti, do.
As you should be able to hear, distortion can have a dramatic and damaging impact on recordings. But distortion can be used for creative and musical purposes as well, typically by electric guitar players who often overdrive their amplifier circuits in order to get a distorted sound. I will demonstrate this by playing a recording of an undistorted electric guitar, both without and with the limiter in line. I have tweaked some of the limiter settings. I have set the threshold down to minus 18 dB and put a makeup gain of 6 dB. This suits the recording better. I'll set this into bypass and play the recording. If you watch the oscilloscope display, you should see the green signal line peaking well above the red threshold line. Now, if I put the limiter back in line, you should see and hear the difference. As you can hear, the addition of some distortion adds a sweet tonal characteristic to the guitar sound. So in summary, distortion is normally something we should avoid when recording, and we do that by watching our recording levels and avoiding clipping, but it does have some musical uses too.